over the last few days, we've been learning how to factor quadratic expressions. So we were taking expressions that were in standard form, such as this one, and following these steps to turn them into factored form at the end. In math, there are a lot of patterns, and if we can recognize these patterns, we can follow them and use them to our advantage to save time, and also to help us solve problems. So learning target 8 says I can factor quadratic functions by recognizing special cases, such as the difference of squares and perfect squares. Now, recognizing special cases, if we think about special cases, really that's just talking about patterns. We're looking for patterns, and when we find these patterns, we can use these patterns to help save us time. The first pattern that we're going to talk about is the difference of two squares. The difference of two squares is an easy one to remember because it literally is the difference, that's the minus sign right there, of two perfect squares. X squared is a perfect square because it is x squared, and 9 is a perfect square because it is 3 squared. So we have this difference, that's the minus sign of two squares. It cannot be the sum of two squares. This cannot be a plus sign right here. It has to be minus for this to work. So whenever you have this difference of two squares, such as x squared minus 3 squared, and here there's x squared minus, that's really like 10 squared. Or here it's x squared minus 2 squared. This is actually 2x squared minus 1 squared. Okay, this whole entire first thing is a perfect square. And here, this whole thing is a perfect square to begin with. It's 4x squared minus 5 squared. Okay, because the square root of 4 is 2 and the square root of 16 is 4. Now, whenever you see this situation, they actually follow this pattern. Whenever you have this, I'll show you on this first one and you can see why that pattern works. So really, this is x squared plus 0x minus 9, right? Because there's no b term in there. We just have the a and the c. So b is actually 0. So we need two numbers that multiply to be negative 9. That's the AC. And that add to be 0. That's the b. So they need to multiply to be negative 9 and add to be 0. And the two numbers that do that are 3 and negative 3. 3 times negative 3 is negative 9. And 3 plus negative 3 cancels out to 0. So when we rewrite this, we get x squared plus 3x minus 3x minus 9. And when we factor then, turns into that, we can take an x out of the first one and we get x plus 3. Minus, we can take a 3 out of this one and we get x plus 3, right? Because negative 3 times positive 3 gives you the negative 9. So our first factor that we can pull out of both of them is x plus 3. And when we pull that out, we're left with an x over here and a negative 3 right here. Okay? So, when we have x squared minus 9, the difference of these two squares, our final answer is x plus 3 and x minus 3. That's how the pattern is. You take the square root of x squared, which is just x. You take the square root of whatever this number is, which is just n, and it's x minus n and x plus n. The order doesn't matter. You could say x plus n and x minus n, but as long as you have one of each. One of them has to be minus and one of them has to be plus. So let's look at this one. We have x squared minus 10. Well, the square root of x squared is just x. The square root of 100 is 10. So we have two perfect squares because when we take the square root of them, we get a whole number. This is like x squared, this is like 10 squared. So our answer is going to be x minus 10 x plus 10. And that's it. Here, that's like an x, that's like a 2, because x squared is really x squared, and 4 is really 2 squared, so your answer is x minus 2, x plus 2. Here, this one, the square root of 4x squared is actually 2x. Okay, because the square root of 4 is 2 and the square root of x squared is x. And the square root of 1 is 1. So we end up with 2x minus 1, 2x plus 1. The square root of 16x squared, the square root of 16 is 4, the square root of x squared is x. The square root of 25 is 5. So we have the difference of two perfect squares, so we end up with 4x minus 5 and 4x plus 5. So whenever you have this pattern of two perfect squares and a subtraction sign in between, it's always whatever the square root of this is. So in this case it's 10, x minus 10, x plus 10. Here it's 2, so x minus 2, x plus 2. Square root of 1 is 1, so 2x. This turns into 2x because the square root of 4 is 2 and the square root of x squared is x. So it's 2x minus 1, 2x plus 1. It's always the square root of each of these. One's minus, one's plus. The other pattern that we can follow is perfect squares. So perfect squares are a little bit more difficult to recognize. You can still factor them the old way though. So this is not something that you need to learn, but it might take you time or save you time. So if you look at this, perfect squares, you can recognize because this has to be a perfect square right here. And then if you take the square root of that, so in this case it'd be 3, this is 2 times whatever that is. So the square root of 9 is 3, 2 times 3 is 6. Over here the square root of 16 is 4, 2 times 4 is 8. The square root of 25 is 5, 2 times 5 is 10. The square root of 1 is 1, 2 times 1 is 2. So whenever you have that situation, the answer ends up being, if this is a plus sign, it turns into this. X plus whatever the square root of this is squared. And if this is a minus, right here, so like in these two, right here, there's a minus sign right there. It's whatever the square root of this is. So in this one it's a plus, so I'm looking over here, I'm going to say x plus 3, because 3 is the square root of 9 squared. And I know I can do that because the square root of 9 is 3, 2 times 3 is 6, which means this actually is a perfect square trinomial. It's a trinomial because there's 3 terms, and it's a perfect square because it's actually x plus 3 times x plus 3. For this one, the square root of 16 is 4, and that's a plus sign right there, so I'm going to do x plus 4 squared. This does not work if this is a minus sign. This last one has to be a plus sign. The first one can change. If the first one is a minus sign, then it's going to be x, and then that's square root of 25 is 5, so we're going to say minus 5 squared. And over here, square root of 1 is 1, so it's going to be x minus 1 squared. If you don't like the squared up here, you could also write it like this, x plus 3 times x plus 3. Because squared means you just multiply it by itself. So we take x plus 3 and we multiply it by x plus 3. This could also be written as x plus 4 times x plus 4, x minus 5 times x minus 5, or x minus 1 times x minus 1. They're the same thing. Because squaring something just means you multiply it by itself. And those are two patterns that if you can recognize will potentially save you time.